Okay, everyone, let's see how long this video takes me to do. I say 6 minutes or less. So first thing we're going to learn about or review, because you've heard of these types of plots before, are stem and leaf plots. Stem and leaf plots are simply these. The stems are the leftmost digit or digits, and the leaves are the rightmost digits, most digit or digits. In practice, the leaves are usually reserved for the very last digit. The stems, especially if they're 3 and 4 digit numbers, can be all the other digits but the final digit. All right, so let's do a stem and leaf plot right now on example 1. I noticed that we're going from the 10s all the way up to the 60s. So my stems are going to be 1, 2, 3, 4, 5, and 6, and my leaves will be as such. I notice there's a 10 and an 11, and a 15. So with no commas, I'm just going to write a 0, a 1, and a 5. That's it. That represents 10. That represents 11. That represents 15. Then we have 23, 27, 28. So keeping the columns organized, 23, 27, 28. I want to see if there's more data in a particular row. Then we have the 30s, 38, another 38, 39, and 39. 40s, 41, 44, 40, 41, 44, 45, 46, 46, 45, 46, and 46. Then there's a 52, 57, 58, 2, 7, 8, and a 65. Ladies and gentlemen, I've just created a stem and leaf plot. Advantages of a stem and leaf plot. It preserves all the data. You could see every single number. Another advantage of a stem and leaf plot, if you look sideways, angle your head to the right, you could see the general distribution of the data. Another benefit of a stem and leaf plot, you could find things like the mode very easily. I could see that I have 246s, I have 238s, and 238s and 239s. It's a trimodal set of data. I could find the median too, count in the middle. Disadvantages of a stem and leaf plot. There are not many numbers here. If there were 500 numbers, I would not want to create a stem and leaf plot. I would want to group the data and create a frequency table or frequency distribution. All right, so there's a stem and leaf plot. Let's go over the one final plot of this lesson. There's another stem and leaf plot example. There, you can make a key. By the way, the key here would be that 1/0 represents 10. Okay, the key here, I could say that 21/7 would equal 21.7. You just need a key to represent the numbers you're talking about. Okay, and then you can make your stem and leaf plot that way. One final graph that can measure distributions is called a box and whisker plot or a box plot. So it says, when exploring a collection of numerical data, we want to be sure that we investigate the value of a representative score. Okay, what is it? The measure of scattering or variation, okay. And the nature of the distribution, like we spoke about in our last lecture. Is it bell-shaped? Is it skewed in a certain direction? A box and whisker plot allows us to find out this information. And here's a set of data, and a box and whisker plot only requires a 5-number summary. It requires the minimum value, the first quartile, the second quartile, otherwise known as the median, the third quartile, and the max. Those are the 5 numbers we need. I'll give you the best information ever. Where could we find all that information? We could just find it doing 1var stats, and then by scrolling down. So I happen to have the data all set up. There's all the data from that list. So if I go to stat and I go to calc and I do 1var stats, I make sure L1 is my list, no frequency list. Just go down to calculate. Yes, the mean is 87.1. The standard deviation is 48.13, but that's not what we're looking for here. I need to scroll down. And from here on down, I've got my minimum, first quartile, median, third quartile, and max. There's my 5-number summary directly from 1-bar stats. So let me just write that currently. We have 10, we have 55, we have 88 for our median or our Q2. We have 123.5. And last but not least, we have 160. One of the keys to doing this is to make a uniform x-axis. So if I start here at 0, I'll go by 20s. 20, 40, 60, 80, 100, 120, 140, 160, 20. I need to see an x-axis that remains consistent. I'm going by 20s each time, 160. First thing I'm going to do is I'm going to draw my median at 88 above here. 88 might be right about there. Then I'm going to draw my quartiles. First quartile is at 55. So I'll put a part of my box right there. Other part of my box is at 123.5. So I'll put it right here, 123.5. Then with my Q1, Q2, and Q3, I create the box of my box and whisker plot. Last but not least, I go and I just make my whiskers. One here at 10, and I connect the whisker to the box, and the other here at 160, and connect the whisker to the box. Okay, so what are the benefits of a box and whisker plot? Well, a box and whisker plot can show you the distribution of data, because remember, the quartiles break the data into quarters. So in other words, 25% of the data is in this box, 25% of the data is in this box, 25% of the data in this whisker, and 25% of the data in this whisker. What does that actually mean? Suppose there's 20 numbers in a set of data. That means 5 numbers are in this part of the whisker right here, the left part. 5 numbers are within this side of the box, another 5 within this side of the box, and another 5 within this side of or this whisker right here. When we write a box and whisker plot or create one, we focus more on the box than the whiskers. Think about what could extend the whiskers abnormally long. The outliers, if there are any, could extend the whiskers abnormally long. The box represents the middle 50% of the data. Okay, that's it. I need a consistent number line on the x-axis, and I need a consistent box and whisker plot. The last thing I want to show you is this. Give me just 1 second. I want to pull it up, and then we'll get to it right here. So let me, yes, I want to add to your class notes. Okay, so we created these notes in class. So the one thing I want to go over right now very quickly is how a box and whisker plot can also show you about the distribution of data. Let me use a different color pen. I'll use green here. So if I drew a box and whisker plot here and superimposed it, my box would be from here to here and here. But I want you to notice something. Notice that my box, while centered, is symmetrical. Okay, even though the tails look longer, the box is fairly symmetrical. If I make a box and whisker plot of data that's skewed, here's my Q2, here's my Q1, and there's my Q3 way out here. Take a look and see how that right side of the box is extended. Remember, skewed means stretched. So see how the right side of the box is stretched on the right-hand side? That lets you know that the data is also skewed to the right. Alternatively, if data is skewed to the left, that means here's Q2, here's Q1, and there's Q3. Take a look at that left box right there. Does everybody see how that left box is stretched or skewed on the left-hand side? So the box is what you're keying in on. The box lets you know whether the data is symmetrical, skewed right, or skewed left. That is it, everybody, and I hope this is a good lesson.